Geometry, Unit 11, Section 4, Perpendicular Points and Slopes. So what we're going to see here is what happens to a point when it's rotated around another point. Um, so to start off, we're going to start off rotating about the origin because that's the simplest way to go here. A couple of things we need to know going into this. We need to know the slope formula is going to be helpful. The slope formula is a formula you should be familiar with from, I guess, Algebra 1. And it is y2 minus y1 over x2 minus x1. And it's actually also written on the next page if you're following along with my class handouts. So the slope formula is given to you there, and it's the change in y over the change in x. And we're also going to need to know that perpendicular slopes, that a perpendicular slope is the negative reciprocal. And this is also something that is going to be covered in the next topic too, reciprocal. Negative reciprocal slopes. And really what that means is, um, flipped upside down, changing the signs. For example, if we have a slope of 2 over 3, perpendicular to 2 over 3, the negative reciprocal of that would be negative 3 over 2. Reciprocal means flipping a fraction upside down, and we're also changing the sign of it. See, perpendicular slopes, always one of the slopes is positive and one of the slopes is negative. We can't have two positive slopes. You could have two positive slopes that just wouldn't be perpendicular. And same thing for negative. And remember, when you're negating a fraction, you negate the whole fraction. It's not that the 3 is negative and the 2 is positive. I mean, this is the same thing as 3 over negative 2. It's not that one of those numbers is negative. It's that the fraction is negative because one of the numbers is negative. We don't really know which one just looking at it like this. We tend to put the negative sign on top, but that doesn't really necessarily mean the top is negative, and that can be confusing. Another example is if we have a slope, I'll do it over here, a slope of negative 1/2. What's perpendicular to that would be a positive 2 over 1, for example. And we're going to talk a lot about perpendicular slopes in this lesson and also the lesson after that, and really going forward, it's a big thing. So we're given points A and B here, and point A is the coordinate 3, 2, and point B is the coordinate negative 4, 1. But I'm not going to worry about B for now. In fact, I'm not going to do these questions here just to save time in the video. You don't need to see it twice. And what we're doing here is we're going to rotate counterclockwise about the origin. And that's our point 0, 0 in the middle here. So I'm rotating point A counterclockwise about the origin. And I could do it with B also, but that would just be a kind of a waste of time, because what we're really going to be seeing in this lesson and practicing mostly is what happens when I rotate these points around each other, not around the origin. And that can be very difficult. So let's go through this for just point A and just the origin. And we're going to rotate counterclockwise. Now, if you're not told which direction to rotate in, it is counterclockwise by default. That is the default rotation direction, is counterclockwise, not clockwise, which is maybe a little counterintuitive. If I wanted you to go clockwise, I would have to say clockwise, or I could also give you a negative rotation, which means the other way. So if it doesn't specify rotation direction, counterclockwise is the default. So rotate point A about the origin. And a big thing we want to do here is we want to use slope. So what is the slope connecting A and the origin? And because I have a graph, I could just count boxes. If not, I could do the slope formula, y minus y over x minus x, and so on. So the slope from the origin to A, the slope is, I see it's going, up 2 over 3. And so the slope would be 2 over 3. And it's a positive 2 over 3 because this connection here would be a incline left to right, not a decline, right? A negative slope would look like that. Going left to right is going down. So it's a positive 2 over 3. Let me just write that again. Didn't mean to erase it. Positive 2 over 3. Can erase this line, though. Now, before I get to rotating 90 and 270, because 90 and 270 are the perpendicular rotations, but 180 is not. 180 is really easy. 180 is just opposite side. It's two 90s together. So you don't need to do perpendicular rotate something 180. just what is the slope here? It's, 2 over 3. We'll do that the opposite direction. So instead of up 2, right 3, we're going to go down 2, left 3, and it would land right over here. And that would be your 180 rotation for point A, -3, -2. So that has nothing to do with perpendicular. That's just, they would be on the same line, continuing the slope, half the circle away, 180 degrees away. But how about 90 degrees? And that's our most common rotation we're going to see in this chapter, is rotating 90 degrees. And remember, we're rotating counterclockwise 90 degrees. So you could probably guess it's going to land somewhere over here. And this is perpendicular because we know perpendicular lines form right angles, and right angles are 90 degrees, and so on, so on, so on. So what I need to do is I need to know, all right, the slope here is up 2 over 3. What is perpendicular to that? Perpendicular to 2 over 3 is -3 over 2. And we actually use that same example up here, right? -3 over 2. And so that means you're going to change the y value by 3 and change the x value by 2. But again, this -3 over 2, I don't know if that's -3 over 2 or if that's +3 over -2, because the fraction's negative. It doesn't really specify which number is negative. And so I don't know if I should change the y by up 3 in this case or down 3 in this case. And I don't know if I should change the x by right 2 or left 2. But it's going to be one of those. And and it's always from the point of rotation that we're doing this change from. So again, the slope connecting these is 2 over 3. The perpendicular to that is -3 over 2. And from the origin, -3 over 2, down 3 over 2 this way, and up 3 over 2 this way. And these are the two 90-degree points, but one of them is 90 degrees and one of them is 270 degrees. And on the graph, it's easy to tell which one's 90, this one's 90, and this one's 270. This 270 could also be thought of as 90 clockwise or -90, right? The graph's very helpful here for a visual. If you don't have a graph, and I'm going to show you how to do that down there, it gets a little bit harder, but figure out what the slope is connecting that, and then do a perpendicular slope from the point of rotation. That'll give you those answers. So -2, 3 is the 91, and 2, -3 is the 271. And there's actually rules for when you're doing this around the origin, but we don't really bother to teach them anymore because most of the time you're not going to be going around the origin. You can be rotating points around each other. So let me state the coordinates again for us. A is 3, 2, and B is, I think, -1, 4. Let me check that. Yeah, -1, 4. All right, so I'm asked to rotate, line segment AB is rotated about point B. And that's important to know which is the point of rotation. So the point of rotation is B. The point of rotation is point B. Where will A land? So first thing I need to know is what is the slope of AB? And that's really where we want to start, is doing our slope formula. So I equals, that would be 4 minus 2, subtracting the y's, and -1 minus 3, that is 4 minus 2 is 2, and -1 minus 3 is -4. Now, this slope can be reduced to -1/2, but I don't want to reduce it, because if I reduce it, that's going to change my distance. And I want to keep the same distance of 2 in one direction, 4 in the other direction. If I did the Pythagorean theorem with these, that would give me, a hypotenuse length. I want to keep it that way. So I'm going to keep my slope unreduced when I'm doing these questions. All right, so that is the slope of AB. Its perpendicular slope would be a +4 over 2. Okay. Now, this is where it gets tricky. And to be honest, I do think this is one of the hardest things we do all year. And especially when you don't have a graph. Now, we have one up here, but let's pretend we don't. What would we do if we didn't have a graph? Now, on the back of your Regents exam, you have a scrap graph paper. So I recommend using that, especially for this type of question. But if we don't have a graph, I think it's worth it to draw a sketch, because you want to know which of these points is on the left and the right. And that's helpful for kind of figuring out, is my rotation point, should it be above or below my point of rotation? You know, and I think that's really the key. So A is 3, 2. That's over here. And B is negative 1, 4. So negative 1, 4, so that's over here. And it's important to know that the point of rotation is the left point. And then when I rotate this 90 degrees around B, 90 degrees, we're going counterclockwise, it's going to land somewhere over here. And it's helpful to recognize that my new point, my answer, is above point B, because that means I'm going to be using point B as, you know, what I change the numbers to. I'm going to increase the y value. All right, so point B is the point negative 1, 4. And I know my perpendicular slope is 4 over 2. I need to change the y value by 4. So it's going to be a plus 4. And I need to change the x value by 2. So plus 2. And that'll give me the point 1, 8. And that's my final answer. That's where this point would be. And you see, you know, if I were to connect these, 1, 8 would be somewhere, it's actually off the grid. It'd be somewhere, you know, up here, 1, 8. But that does look like it would be a 90-degree rotation. So I really think using that scrap graph is helpful here. The other thing is, doing the sketch is helpful because if I wanted to rotate 270, I'd be somewhere over here. I'm not going to add 2 and 4. I'd have to subtract 2 and subtract 4. Because, again, 4 over 2 is my slope. That's equivalent to negative 4 over negative 2. So just as when you have a negative slope of negative 3 over 2, I don't know which number is negative. Well, if you have a positive slope, that's the same as both negative. And so you need to kind of make the decision of, should I be adding or should I be subtracting? And this is, like I said, it's a very, very challenging thing. I'm going to spend a lot of time talking about this in class. I find it to be one of the more difficult things for me personally to teach. So I'm going to make sure to try to hit this as well as I can the next couple of days. All right. So there's another example here, but video is running a little late. We're gonna do this in class and spend a lot of time on this. All right. See you.